Hi, my name is Jagdish Nayak. I work for Cycuity and I'm at DAC 2023 and I'm going to show you my solution for security hardware verification. So security is very important nowadays, especially in hardware, because there's all kinds of attacks, and what you really want to do is make sure that you catch your security vulnerabilities before it is taped out so that it's less expensive to fix it and you are more confident about your product. So what Cycuity does is we have a methodology where we have a security process which involves security requirements collection, security verification, and then security sign-off. So how does this work? So we first allow customers to gather their security requirements from the security architects, and then we convert them into radix rules, which are this conversion of the security requirements into the RTL. And now once we convert them into connect the requirements to the RTL radix rules, we then run radix to allow you to track information from your secure assets to illegal destinations. And if there are violations, we allow you to use our analysis tools to find out how the information got from source to destination and then fix it. And then finally, we have a security sign-off process wherein all the information that you guys get from a verification can be logged in and can be correlated with the security requirements to give you higher security assurance so that you can feel confident when you tape out your chips. So how does this actually work in a verification environment? First, what we do, we look at your design, we look at your security rules, we run radix once, we create something called a security monitor. So your security monitor can be considered as another piece of IP that you can put in your verification environments. It has already analyzed your design, looked at your rules, and then created this IP that tracks information from the source to the destination. The next step is then taking the security monitor, putting it in a verification environment, and running it in simulation or emulation, and running all your existing test vectors. So what this does is it does not affect your RTL because it's just verification IP. You run it in simulation or emulation. You can run it with Synopsys, Cadence, or Siemens emulation or simulation tools. And then if there is a violation, you get a waveform dump. You take the waveform dump and use radix analysis tools to kind of verify the path from source to destination and then fix it. One of the advantages of radix is that when you use it with emulation, you can actually run it with production firmware and software to make sure that there are no bugs that are exposed in your hardware if there are issues in your firmware. Next, I'm going to talk about an actual customer case in which we found security weaknesses in an existing design. So here we have an AES block that can take cipher keys, it can decrypt them and then store them in this public key, in this plain text key table that can be used later on to convert your user information through the AES block and then use it later on in your boot image. So the worry here is that there is a possibility that the cipher key can actually leak out on the plain text bus. Remember, this design has two functionalities. One is to take cipher keys, decrypt it and store it in an internal key table. And then the second functionality is that it can actually use user-level firmware to be decrypted in the AES block and then send it out on the plain text bus to the block that follows. So the worry here is that the cipher keys that will get decrypted, and somehow there may be information that leaks out from the AES block all the way down to the plain text bus. Now this is an actual problem that happened. What happens is that there are remnants of the ciphertext key that were decrypted and saved in the AES block in the various pipeline stages, and that leaked out during just normal, regular, functional running of the block. This kind of bug or this kind of security weakness cannot be identified or located by functional verification. So information flow tracking allows the user to catch issues like this much in advance. Then finally, what radix does is it allows you to find issues at the block level then you can use the same rules that we used to find issues at the block level at the subsystem level, and then finally use the same rules as well as you can add more rules and run them at the system level. So what this allows the user to do is expose issues at every level in your design before you tape out. So it provides a complete solution using information flow tracking to find any bugs or security weaknesses as your security assets flow in your design from IP level to subsystem level and to block level, so that when you finally do security sign-off, you're confident that you are taping out a secure chip. Thank you.